So good morning, everyone. My name is Jan Musiał. I am not an employee of the paying agency. We work for a small institute of Geodesy and Cartography, remote sensing center in Poland, in Warsaw. But we work with our paying agency in the framework of ESA projects. And at the beginning, I would like to also acknowledge my colleagues who are also working on this topic. It's Jędrzej Bojanowski and Sylwia Sikora. So as I mentioned, we work for our paying agency, but also for statistical office. And this is within the ESA project EOSTAT. Which basically has two end users. One is the paying agency and the second one is the statistical office. And our institute is responsible for this project, as well as Polish Space Research Center. And the aim of this project at the beginning was to support Polish statistics with the crop type classification using Sen2Agri at the beginning and further Sen4CAP. Monitoring of the crop growth condition on low resolution satellite data. So here it's Sentinel-3, and crop yield forecasting and feasibility at the parcel level. And for the paying agency, we were focusing within this project on verification of agriculture activities, catch crop detection, and verification of maintenance of vegetation against erosion. So maybe here at the bottom you have also a link if you want to learn more about the project itself, and maybe just a few words of the introduction about the agriculture in Poland, which is a little bit specific. It's basically there is 1.5 million of agriculture holdings and 10 million of individual parcels, which basically it's quite a challenge to monitor. And in our institute, and also I hope also in our paying agency, we see a need to implement remote sensing and Copernicus data for it, because the on the spot visits or checks are really expensive, and we have to reduce the need for them. So here it's just a brief background how it looks like Poland in the EU. Basically, we have 13 million of farmers. So you can say that every 10th of the farmer is from Poland. And we have quite substantial support from the EU. We are the 5th biggest beneficiary of EU. So there is a lot to monitor. And thanks to Sen4CAP, we were able to run some tests to see how is it feasible to implement CAP monitoring in Poland. So this is our region of interest, located in the, let's say, central Poland. And it's agriculture area with large parcels, which is also important. So what we did, we generated the crop type product from Sen4CAP using 34 different crop types, and the overall accuracy that we reached, it was 91%, and overall kappa was 0.9, which is really amazing, I would have to say. And yes, the data, the classification was run on both Sentinel-1 and Sentinel-2. And maybe what was not mentioned before, and I think it's quite substantial, and it's a good advantage of the Sen4CAP product, is that it gives you the probability of classification and also the second and the third probable class. So as you can see here in the attribute table, the top crop was recognized correctly. It was winter barley, but the winter rye was misclassified. But here you can see that the confidence level in the CT-conf1 column was quite low. So this allows you to further filter the product to be to exclude those misclassifications or the parcels which were really doubtfully classified. This is the plot that is generated by the Serfocat with the accuracy. So here with the blue, with the black dots, we have a cumulative histogram of different crop types, which are marked with code at the x-axis. So we can see that first 7 or 8 even crop types, the main crop types are classified with a really good accuracy above 85%. The second product that we generated was the grassland mowing product. Here it's also, this is how the product looks like, the visualization. And also it's nice that it gives you this 3 different mowing events, up to 3 or 4, sorry, mowing events can be detected with dates. And basically, what we did within the EOStat project, we thought that we should not reinvent the wheel and use basically what was already being developed. So that's why we went one step further and we developed our own phenology, let's say, product, which is based on Sentinel-2. And here you can see that there is a declared crop, but there is a classified crop, and this information comes from the satellite classification. And what you can see here is the greening phase. So this is the beginning of the season, end of the season. Here we have the yellow background. This is a catch crop, which also with the start and the end of the catch crop. And this is the information that we provide to our paying agency. And here on the y-axis, it's the crop cover. So it means 100%. It means that the entire field is covered with vegetation. And yeah, so here you have some coordinates and some statistics about this agricultural field. And the second product that is being implemented now about that use Sen4Cap, it's the crop yield forecasting. So now we have learned that the new Sen4Cap version 2.0 provides marker database along with the crop classification and vegetation status products. And fusion of all of these data sets allows for improvement of our crop yield forecast, which we do for our statistical office. So here on the left, you can see the forecast itself. Our forecasts are those gray bars. The blue dots are the forecasts of our statistical office. So you can see that in some places they are close, but for some voivodeships or regions in Poland, they are a bit apart. And integration of satellite data greatly improves our accuracy. And what we do, we do this for here you can see the error, which is up to 2%. And basically we do this for the smaller regions, and then we aggregate this information to voivodeship, and this is what our statistical office uses further. And we were talking a little bit about the ideas for future Sen4Cap. So what we have to state that in Poland, around 50% of agriculture field can be analyzed with Sentinel imagery, because they are another half is a bit too small, in a sense that you can see it on the left. This is the large fields, but we have loads of those small parcels where the Sentinel imagery it's too coarse resolution, and that's why we need new Sen4Cap system capable of processing VHR imagery which is 3 meters and lower. And here just an example of such imagery. This is a Sentinel-2 image, and here you can see this is the planet image. So with such a resolution, we would be able to resolve way more agriculture fields in Poland. The tests were run on the Sen4Cap tests were run on the Geodesy, and here you have a URL for with the information. Thank you very much for your attention.